Hello friends, it's Arun Singh here back with my new video on Java multithreading. Let's see further. Process versus threads. Process is equal to multiple applications running simultaneously in the server, PC or Mac. Thread is equal to multiple tasks running within a process. If you will go to your task manager, you will see something like this. If I have opened Firefox, then this is my percentage of CPU usage, this is my memory usage, this is my disk usage, and this is my network usage. If I talk about IntelliJ, it is using 0% CPU and this much MB of memory. Again, disk and network is 0. But you will see of my Firefox there is mentioned 12. This show the number of tabs that I have opened for Firefox. And this is total CPU and memory usage I have of them. If you will go to resource monitor, in the resource monitor with CPU usage, you also have the thread counts. If you will see, I have Skype running at background. This is my process ID. This is the description. This is the status. And these number of threads it is taking. CPU usage is 0. If we will talk about Firefox, this is my process ID running at background and these number of threads are running for it. CPU usage is 0 for it, but average 0.35. There is one more instance of Firefox is running for which 8 number of threads are running. So by resource monitor you can see the process ID and the number of threads running over it. If you will go to right hand side of it, you can see the graphical usage of CPU, disk, network and memory. What are threads? A thread is an independent path of execution within a program. Many threads can run concurrently within a program. Every thread in Java is created and controlled by the java.lang.thread class. A Java program can have many threads and these threads can run concurrently, either asynchronously or synchronously. Multithreading has several advantages over multiprocessing, such as threads are lightweight compared to processes. Threads share the same address space and therefore can share both data and code. Context switching between threads is usually less expensive than between processes. Cost of thread intercommunication is relatively low than that of process intercommunication, and threads allow different tasks to be performed concurrently. Selection number of threads. Why I am putting this question? Let's say I have one Java program. The question will come, how many number of threads should I open? The answer should come, how many core of CPU process you have. If I have quad core, 4 core, that is maximum 4 thread can run execute at one time. So in this case, if I am running on a thread, so I need to create only 4 threads for my application. You can have 16 threads, you can have 32 threads, but at single instance only 4 threads can run. Now, if your thread has a long running task, like it is running from a file, and one thread takes 5 minutes, and in this case, you are breaking your application into 5 threads. That means your 4th thread will take 4 cores maximally, and your 5th thread definitely have to wait. There is a definite word with the 5th thread. I will not say that 4th thread will take all the 4 cores, right? This is in the hand of operating system. But in a best case, if all the 4 threads takes the quad core CPU, but the 5th thread definitely have to wait for that 5 minutes. So in this case, giving a 5th thread is not a, or opening a 5th thread or starting a 5th thread is not a better architectural choice. So your thread should take less time, and if it is taking less time, you can increase the number of threads depending on your application. Inside working, when a Java application starts up, main thread is spawned by the Java project. This is the application entry point. From this point onwards, entire application logic is executed either in the main thread or the threads that we spawn from within the application to either achieve concurrency or parallelism. Fine. Application logic executed by threads involves computation being performed in the CPU, while the result of the computation is stored in the RAM. When I said RAM, that is random access memory. That is, I am taking use of the memory of the system. Each thread will wait for its turn to use one CPU core to perform computation and a local memory area, stack and multiple frames within the stack for each method call. I want to point one thing back here. Threads takes the memory from the stack. When you create an object, like say I have a class public class test out memory, and I'm creating an object with new operator, this object will take memory in heap memory. Now I have a my method in which I am passing a parameter p. I am passing some value, but I am giving a local value of p is equal to 1 here. This method call is stored in stack memory. On the similar fashion, when you have open a new thread or start a new thread, they go and take memory from the stack. Once the thread completion code execution, it typically flushes the result back to RAM pool. That means once the thread execution is completed, your stack memory get clean heap memory. All the objects created within a Java application is allocated space in memory called heap. These objects live as long as it is referenced from somewhere in the application. Heap memory is garbage collected to free up precious space by removing objects that are no longer used within the application, while the memory space held by the stack is freed up once the thread of execution complete. Stack memory will only get free up when the thread execution gets finished, and heap memory will only get garbage collected when any object which is getting referenced is now no longer used. Stack memory. Thread executing a method or invoking a series of methods would need space in memory for storing local variables and methods arguments. This memory is called stack. Each method called by the thread is stacked on top of the prior method call, called stack frame. Conclusion: heap is the shared memory area among threads where all the objects live, and stack is the private memory area allocated to each of the running thread. Let's see a thread lifecycle. Thanks.